Welcome to an overview of Amazon Route 53. Amazon Route 53 is a highly available and scalable cloud domain name system that provides a reliable and cost-effective way for developers and businesses to route end users to internet applications. This is achieved by translating names like www.example.com into numeric IP addresses like 192.0.2.1 that enable computers to connect to each other. Amazon Route 53 is also fully compliant with Internet Protocol version 6. Amazon Route 53 connects user requests to infrastructure running in AWS, such as Amazon S3 buckets or Amazon Elastic Load Balancers, and can also be used to route users to infrastructure outside of AWS. Amazon Route 53 traffic flow simplifies traffic management globally through a variety of routing types, including latency-based routing that routes users to the AWS region that provides the lowest possible latency, GeoDNS routing that routes users to a particular endpoint that you specify based on the end user's geographic location, geo-proximity routing that routes traffic to your resources based on the geographic location of your users and your resources, weighted round-robin routing that specifies the frequency with which different DNS responses are returned to end users, and failover routing that lets you route traffic to a resource when the resource is healthy, or to a different resource when the first resource is unhealthy. You can also use Amazon Route 53 Application Recovery Controller to configure DNS health checks that continuously monitor your application's ability to recover from failures and control application recovery. Amazon Route 53 has a simple web services interface that lets you get started in minutes. You start by creating an Amazon Route 53 hosted zone that can store DNS records for your domain. Once you create a hosted zone, you receive 4 Route 53 name servers to help ensure a high level of availability for your applications. If you don't have a domain name, you can create one with Route 53, or transfer an existing domain that you already own, so you can conveniently manage your domain names and DNS configuration in a single location. Your hosted zone will be initially populated with a basic set of DNS records, including 4 virtual name servers that will answer queries for your domain. You can add, delete, or change records in this set using the AWS Management Console or by calling the Change Resource Record Set API. Amazon Route 53 supports many DNS record types, including A records that route traffic to a resource, such as a web server, and CNAME records that allow you to redirect one domain name to another. Route 53 also includes alias records that let you route traffic to selected AWS resources like Amazon S3 and Amazon CloudFront. Welcome to the Amazon CloudFront overview. Amazon CloudFront is a content delivery network which is fast, highly secure, and programmable. Amazon CloudFront allows for the delivery of static and dynamic content, as well as applications. The delivery of this content through CloudFront can scale to millions of globally distributed concurrent users. CloudFront's lightning-fast content delivery capabilities are achieved through a massively scaled and globally distributed network with numerous edge locations, also called points of presence. These points of presence, which cache content, bring cloud services closer than ever to the end user, no matter where they are in the world, or where your main service is hosted. Next, we will discuss some of the benefits of using CloudFront. The first benefit is fast content delivery. CloudFront points of presence are interconnected through the AWS backbone. This backbone is fully redundant and built with a parallel high-speed Ethernet fiber network. Connection to this AWS network backbone vastly reduces latency, effectively increasing customer speeds. Moreover, to further decrease latency, CloudFront uses a multi-tiered caching architecture. It also intelligently routes your content to the most performant edge locations, based on your end-user needs. The next benefit is CloudFront's cost-effectiveness. CloudFront offers personalized pricing options including pay-as-you-go and custom pricing. Pay-as-you-go pricing is simple, with no upfront fees. However, for steeper discounts, consider using custom pricing. Custom pricing requires minimum traffic commitments, such as 10 terabytes per month. Custom pricing may also include bundled discounts. Customers can see large security service savings of up to 30%. CloudFront also offers origin savings. Origin fetches are free for content, if the origins are simple storage service, elastic load balancers, or elastic compute cloud. CloudFront also makes use of regional edge caches at no additional cost. Regional edge caches can reduce the total operational costs and burden. Another benefit of CloudFront is its integration with AWS. CloudFront provides deep integration with AWS services such as simple storage service, elastic compute cloud, elastic load balancing, and elemental media services. This deep level of integration improves developer and DevOps efficiency. Developers have a full-featured API to create, configure and maintain CloudFront distributions. In addition, developers have access to a number of developer tools such as AWS Code Deploy, Code Commit, and AWS SDKs to configure and deploy their workloads with Amazon CloudFront. Developers will also have ability to manage infrastructure with tools like CloudFormation, and can get a host of metrics and logs with CloudWatch integration.
Amazon Simple Storage Service Overview. Amazon Simple Storage Service, or Amazon S3, is an object storage service. An object consists of both data and attached metadata. The metadata is a set of name-value pairs that describe the object. Buckets are containers for objects stored in S3. An object is uniquely identified within a bucket by a key. For example, an image file is uploaded to a uniquely named S3 bucket. After the file is uploaded, it becomes an object, which contains image data and any added metadata, such as time created and location. Amazon S3 offers industry-leading scalability, data availability, security, and performance. Customers of all sizes and industries can use it to store and protect any amount of data for a range of use cases such as websites, mobile applications, backup and restore, archives, enterprise applications, IoT devices, and big data analytics. Amazon S3 can use and big data, backup and restore, archives, enterprise applications, IoT devices, and big data analytics. Amazon S3 can easily meet fluctuating demands by automatically scaling your storage resources up and down without upfront investments or resource procurement cycles. Amazon S3 is designed for 11 nines of data durability. Because it automatically creates and stores copies of all S3 objects across multiple availability zones, your data is available when needed and protected against failures, errors, and threats. Amazon S3 also offers leading security, compliance and audit capabilities. It secures your data from unauthorized access with encryption features and access management tools. S3 allows you to block public access to all of your objects at the bucket or the account level, with S3 Block Public Access. You should enable block public access for all accounts and buckets that you do not want publicly accessible. S3 maintains compliance programs such as PCI DSS, HIPAA High-Tech, FedRAMP, EU Data Protection Directive, and FISMA. To help you meet regulatory requirements, AWS also supports numerous auditing capabilities to monitor access requests to your S3 resources. Amazon S3 is widely supported and integrated with many applications and services. You can choose to work with a partner from the AWS Partner Network, or APN, which is the largest community of technology and consulting services providers. Migration partners can help you to transfer data to Amazon S3. Storage partners offer integrated solutions for primary storage, backup and restore, archives, and disaster recovery. You can also purchase an AWS integrated solution directly from the AWS Marketplace, which lists over 250 storage-specific offerings. Amazon Elastic Load Balancing Overview. Elastic Load Balancing, ELB, automatically distributes incoming application traffic across multiple targets, such as Amazon EC2 instances, containers, IP addresses, Lambda functions, and virtual appliances. ELB automatically scales your load balancer as your incoming traffic changes over time. Elastic Load Balancing is a regional service. It can handle the varying load of your application traffic in a single availability zone or across multiple availability zones. This increases the availability and fault tolerance of your applications. ELB can be internet or internal facing. Internet zones. This increases the availability and fault tolerance of your applications. ELB can be internet or internal facing. Internet-facing load balancers can route requests from clients over the internet. On the other hand, internal load balancers can only route requests from clients with access to the VPC for the load balancer. You configure your load balancer to accept incoming traffic by specifying one or more listeners. A listener is a process that checks for connection requests using the protocol and port that you configure. It then forwards requests to a target group. Each target group routes requests to one or more registered targets, such as EC2 instances. The rules that you define for a listener determine how the load balancer routes requests to its registered targets. ELB monitors the health of the targets and routes traffic only to the healthy targets. You can also offload the work of encryption and decryption to your load balancer so that your compute resources can focus on their main work. Elastic Load Balancing offers 4 types of load balancers that all feature the high availability, automatic scaling, and robust security necessary to make your applications fault tolerant. Now, let's look at each of these load balancers. Application Load Balancer functions at the application level. Layer 7. It is best suited for load balancing of HTTP, HTTPS, and gRPC traffic, and provides advanced request routing targeted at the delivery of modern application architectures, including microservices and containers. Application Load Balancer also routes traffic to targets within Amazon VPC, based on the content of the request. Network Load Balancer functions at the connection level, Layer 4. It is best suited for load balancing of TCP, UDP, and TLS traffic where extreme performance is required. Network Load Balancer can also route traffic to targets within Amazon VPC and is capable of handling millions of requests per second while maintaining ultra-low latencies. It supports static IP addresses. You can also assign one elastic IP address per subnet enabled for the load balancer. Gateway Load Balancer provides both Layer 3 gateway and Layer 4 load balancing capabilities. It listens for all IP packets across all ports. Gateway Load Balancer makes it easy to deploy, scale, and run third-party virtual networking appliances, such as firewalls, intrusion detection and prevention systems, and deep packet inspection systems. It gives you one gateway for distributing traffic across multiple virtual appliances. Gateway Load Balancer also provides auto-scaling for fleets of third-party appliances. It is transparent to source and destination of traffic. They are well suited for working with third-party appliances for security, network analytics, and other use cases. Classic Load Balancer functions at both Layer 4 connection level and Layer 7 request or application level. It supports TCP, SSL, TLS, HTTP, and HTTPS traffic. It is intended for applications that were built within the EC2 Classic network. With Elastic Load Balancing, you can select the appropriate load balancer based on your application needs.
Amazon Relational Database Service. Amazon RDS Overview. Amazon RDS is a managed relational database service. Amazon RDS makes it easy to set up, operate, and scale a relational database in the cloud. It provides cost-efficient and resizable capacity, while automating time-consuming administration tasks, such as hardware provisioning, database setup, patching, and backups. It frees you to focus on your applications. Amazon RDS provides you with 6 familiar database engines to choose from, including Amazon Aurora, PostgreSQL, MySQL, MariaDB, Oracle Database, and SQL Server. You can use the AWS Database Migration Service to easily migrate or replicate your existing databases to Amazon RDS. Here are the key benefits. Easy to administer. Amazon RDS makes it easy to go from project conception to deployment. You can use the Amazon RDS Management Console, the AWS RDS command line interface, or simple API calls to access the capabilities of a production-ready relational database in minutes. You do not need to worry about infrastructure provisioning, installing, and maintaining database software. Highly scalable. You can vertically scale your database's compute, memory, and storage resources with only a few mouse clicks or an API call, often with no downtime. Many Amazon RDS engine types allow you to launch one or more read replicas to offload read traffic from your primary database instance. Available and durable. Amazon RDS runs on the same highly reliable infrastructure used by other Amazon Web Services. When you provision a multi-AZDB instance, Amazon RDS synchronously replicates the data to a standby instance in a different availability zone, AZ. Amazon RDS also has many other features that enhance reliability for critical production databases, including automated backups, database snapshots, and automatic host replacement. Fast. A DB instance is an isolated database environment running in the cloud. You can provision new RDS instances only in a few minutes. Amazon RDS supports the most demanding database applications with fast performance. You can choose between 2 SSD-backed storage options. In addition, Amazon Aurora provides performance on par with commercial databases at 1/10 the cost. Secure. Amazon RDS makes it easy to control network access to your database. It lets you isolate your database instances by running them in Amazon VPC and connect to your existing IT infrastructure through an industry-standard encrypted IPsec VPN. Many Amazon RDS engine types also offer encryption at rest and encryption in transit.
Let's review auto-scaling and auto-healing on AWS. AWS auto-scaling monitors your applications and automatically adjusts capacity to maintain steady and predictable performance at the lowest possible cost. AWS auto-scaling makes it easy to set up application scaling for different types of resources across multiple services. And you can configure this in minutes. You can build scaling plans using a simple interface to manage resources like Amazon EC2 Spot Fleets, Elastic Container Services tasks, and DynamoDB tables and indexes. Scaling is simplified with recommendations that optimize performance and costs, or establishes a balance between them. You can also configure smart scaling policies to calculate the appropriate scaling adjustments that immediately add or remove capacity from your applications based on targeted metrics like CPU utilization. Let's review how AWS auto-scaling can automatically heal applications. In this example, an application is powered by EC2 instances that sit behind an elastic load balancer. The auto-scaling group is configured to have an optimal capacity of 6 instances, spread across 2 availability zones. If an instance in availability zone number 1 is failing, an ELB health check will determine instance health, and that triggers the launching of a new, healthy instance. Now, the application has returned to its optimal state. An auto-scaling group can also rebalance instances when necessary. If availability zone number 1 goes offline, the auto-scaling service will rebalance the instance load by shifting instances to availability zone 2 until availability zone number 1 comes back online, making your applications more available and resilient. Now, let's review how AWS auto-scaling can integrate with AWS services using lifecycle hooks. With lifecycle hooks, you can perform actions on instances in an auto-scaling group based on an event. For example, when an instance is flagged for termination, a CloudWatch event detects the termination call, which will trigger a Lambda function. The Lambda function invokes AWS Systems Manager, and Systems Manager places the instance into a terminating wait state. While the instance is in the wait state, Systems Manager bundles the application logs on the instance into a zip file and stores them in an Amazon S3 bucket before termination is complete. The auto-scaling service verifies with Lambda that the log-saving process is complete before it resumes terminating the instance. With this automation, you can save application logging information before instance termination to aid in diagnosing any application issues.
Amazon CloudWatch Overview. Amazon CloudWatch is a monitoring and observability service built for DevOps engineers, developers, site reliability engineers, and IT managers. CloudWatch provides you with data and actionable insights to monitor your applications, respond to system-wide performance changes, optimize resource utilization, and get a unified view of operational health. CloudWatch collects monitoring and operational data in the form of logs, metrics, and events, providing you with a unified view of AWS resources, applications, and services that run on AWS and on-premises servers. You can use CloudWatch to detect anomalous behavior in your environments, set alarms, visualize logs and metrics side by side, take automated actions, troubleshoot issues, and discover insights to keep your applications running smoothly. Here are some benefits of Amazon CloudWatch. Amazon CloudWatch enables observability on a single platform across applications and infrastructure. Modern applications running on microservices architectures generate large volumes of data in the form of metrics, logs, and events. Amazon CloudWatch enables you to collect, access, and correlate this data on a single platform from across all your resources, applications, and services that run on AWS and on-premises servers. Amazon CloudWatch makes it easy to collect metrics in AWS and on-premises. It natively integrates with more than 70 AWS services, such as Amazon S3 and Amazon DynamoDB, and automatically publishes detailed 1-minute metrics and custom metrics with up to 1-second granularity, so you can dive deep into your logs for additional context. You can also use CloudWatch in hybrid cloud architectures by using the CloudWatch agent or API to monitor your on-premises resources. Amazon CloudWatch also helps you improve operational performance and resource optimization. With CloudWatch, you can set alarms and automate actions based on predefined thresholds or machine learning algorithms. For instance, it can start Amazon EC2 auto-scaling automatically or stop an instance to reduce billing overages. You can also use CloudWatch events for serverless to trigger workflows with services like AWS Lambda and Amazon SNS. And finally, to get operational visibility and derive actionable insights from logs, CloudWatch provides automatic dashboards, data with 1-second granularity, and up to 15 months of metric storage and retention. You can also perform metric math to gain insights, such as aggregating usage across an entire fleet of EC2 instances. You can also explore, analyze, and visualize your logs, so you can troubleshoot operational problems. And with CloudWatch Logs Insights, you only pay for the queries you run. You can then publish your metrics and logs together in CloudWatch dashboards for complete operational visibility.